So, all right, try. Is everybody able to hear me? Valentin, how, Arpan, Sekhar, Giridhar, Abhinav, Sachin, are you able to hear me clearly? Great, great. So everybody can hear me, and let's start now. All right. So, do you want a quick, what do you say, kind of a quick overview of what we have been talking about so far? All right. So, okay. It says, Arpan, for you, it says that the audio is not connected. All right. Maybe something has gone wrong. Never mind. All right. Try disconnecting and connecting again. Great. So everybody is able to hear me, just that since the time I have made him the organizer, he's not able to hear. All right. So quickly, I would like to explain to you in a very quick way what we have been talking about. So Spark in general provides you a way of computing, not the storage. Okay? It doesn't provide you a way to store data. It provides a way of computation. And all right. And the way it does is that you write your Spark application, and in that you clearly tell that on what machine, what are you going to do? You tell that in the form of interaction with the a system called resilience distributed dataset. All right. Now, before that, the way the execution happens is in case of Spark that your program is generally launched at driver application, and driver application talk to every node in the cluster to achieve the results. All right. Now, Spark could run in two modes, either over existing resource manager. Existing resource manager means that you already have Yarn, or you are running on Amazon, you are running on Mesos. You already have something in your cluster which is running and which is basically executing other tasks. All right. If you have that model already, then you don't need to install you don't need to install Spark on every node. You can just utilize that. All right. That is called over the cluster mode. While in the standalone mode, what you have to do is if you do not have the cluster the cluster existing cluster, you can run your application Spark in the standalone mode, just like MongoDB, Cassandra, or others have their own method of execution. Spark also comes with its standalone mode, meaning it doesn't need it doesn't need to necessarily have any other resource manager. Okay, so let's say today you don't have a Yarn or Amazon or Mesos. What would you do is you would install Spark on all the nodes in your cluster and tell all the nodes about each other. and then the cluster will start, and automatically there will be an election, and one of the node will be will be selected as the master node. Okay, and so basically, when you start Spark on all the nodes and you inform each other about other nodes, then they will talk to each other and get your work done. All right. The only downside of standalone mode is it doesn't know about your Hadoop cluster. So if you already have a Hadoop cluster and you want to do some data churning, then Spark since Spark cannot is running in standalone mode, it won't be able to execute logic near the data. Correct? So in standalone mode, that's the downside of standalone mode. Okay, but good news about standalone mode is that if you don't have a dependency on a third party, that's the reason why the standalone mode exists. Valentin's question is, I have heard that Spark standalone mode is for testing only. If starting a new cluster, then should I choose a standalone mode? Yes, you are right. So standalone mode, although just like any other independent solution, makes Spark independent, but it is not a great practice to be. A reason is the reason which I gave you just now. That if you have already a Hadoop cluster or some other cluster, then it doesn't make sense. Second, Spark will be basically, for example, let's say tomorrow you want to run HBase or any other system, then it won't be of any use. Okay, so a better practice is to have your own resource manager and then run Spark. All right, all right. Do I make sense, Valentin? Sekhar's question is, in standalone mode, how is data storage taken care? As we do not have HDFS. Okay. Correct. That's a good point. And yes, so generally, generally it is useless for lots of people, this standalone mode, because it doesn't, Spark does not provide you the storage. The only use case I can foresee is, let's say you have some data in some files locally or in the network, in a NFS or somewhere. Okay, and you want to churn that data using these machines. Okay, in those cases, Spark standalone mode can give you the head start. Instead of waiting to install the whole cluster, you can quickly start with installing Spark standalone mode. Good. Great. Great. So we first talked about two modes. One is standalone, other is over a resource manager. Now, over a resource manager has many things. One, you can install Spark over Yarn. Basically, the beauty of Spark is that you don't need to install over a, a resource manager. All you have to tell is, specifically in case of Yarn, Spark remains like a client. And it basically, when we launch a Spark job or when we launch interactive cell, it's going to get executed over the yarn. And because of the architecture of yarn, which made it possible to execute anything over the cluster, it is very simple and very much possible to run a Spark program without installing on every node. Why? Because when you start a Spark program, it will go with its application master and will run on a container. Okay, so there will be Spark application master which will be running and which will be serving you, and that will run inside a yarn container. Okay, so basically yarn is providing the real state and you are providing the application. So you have, so Spark, when we it starts, it talk to yarn and says, hey, here is my application master, can you run it over the cluster? And when the Spark application master is up and running, then you can get anything done through the Spark app- is through the Spark application master. So those are the beautiful things done as part of the architecture of Yarn, and Spark took the complete advantage of that, and that's why it was successful. Imagine that Spark only provided a standalone mode. The way MongoDB provided only the standalone mode. I'm not sure if they have moved now to complete Yarn. Now imagine that for a system admin managing two installations, one Yarn and other Spark, okay, it will be a nightmare. Okay, then again, as and when you are upgrading Yarn, you will have to keep upgrading the Spark as well separately, as well as you will have to monitor whether Spark is down, up, or what's going on. Third, if you are having two clusters, a Spark cluster and or Spark is independently installed on the same machines on which Yarn is running, what would happen effectively is that you would end up transferring a lot of data because you cannot take the advantage of data locality. Because inside Yarn, when you run a Spark program inside Yarn, it knows exactly what nodes are available near which data. Okay, because that's something Yarn brings to the table, that hey, I know where data lives and I know how to execute anything near the data. Therefore, running a Spark program inside a Yarn or inside any other resource manager makes more sense than running in the standalone mode. All right, good. Good, great set of questions. Moving ahead, so we earlier talked about running in the standalone mode, and then you can run we ran an example of computation of pi. So is this idea of computing the pi clear to everyone, or do I need to explain again? How was the work of computing the value of pi done? Okay, it is nothing but, let's not confuse it. Let's talk about that. Say you do not know the formula of computing the area of a circle. Okay, let's say you do not know the formula for computing the area of circle. So what you do is you slice, you iterate over, how should I say? You break down the whole circle into the grid of very small squares, and then you count those squares inside that grid. All right, that's all is about finding the area of a circle. All right, if you think about area, what is area? Area is something, the space covered by a, covered by a shape, right? Now if you cut down this shape into small pieces, small squares, then those number of squares, if you count, you can easily tell that this is the area of the shape. Okay, so even for irregular shapes, if you just break it down into very small squares and then you count those squares, number of squares being occupied by the shape, then you will be able to tell the area of the shape, right? Now all you have to do is, in case of this this whole program, what it does is, I have mentioned the GitHub source code for them. Okay, you can see that, as well as you can see the strategies of counting the area of circle. Now, if you think about it, you will have to count too many squares. If you break down the circle into it's very small, say few billion mm, squares. Okay, few billion squares if you break it down. So the work of counting squares will be too high. You will have to check whether the square is inside the circle or not. If it is inside, then you have to say yes, it is inside and count. So you can make this process of counting squares distributed by dividing the space into sections and delegating the work to different n- nodes. Okay. All right. Now, so that's how it was done. So go through it. If you have a question, let me know. I can explain this in more detail. Or if you want to go through this piece of code, you go through that piece of code. If you can't figure out what's going on, then we will discuss it again, maybe in the next session or sometime. Okay. I want to give you more time to go through it. Please make notes of it, that you have to go through understanding how the work has been divided here. Okay, or it will be more convenient at later point of time when we understand RDD to explain the code. Okay, I would love to explain the code. Please remind me, maybe in the second session or next session or next session. All right, now you see these three things here. Okay, the first one is you are running the you are running this Spark program in standalone mode, meaning run it locally only. Okay, run it locally only. Second is, so it's actually three, not two. Okay, so you are running in a standalone mode by using master local. I'll show you. If you, instead of local, if you say yarn client or yarn cluster, it'll get executed on the yarn. All right, these are the various binaries you should know of. Okay, and then this diagram shows that if you are running Spark program on yarn, this is how it's going to look like. This is yarn client mode. What does it mean by yarn client mode? As we have told you earlier also, that Spark program is made up of two parts. One, each individual Spark application, and driver application. So driver application is a sequence of steps to be executed, to be the work to be given to Spark application. So this driver application keeps track of what is going on and how to execute the whole process. Each individual work is done by Spark application, while driver application is kind of a master sequence of work. All right. So this driver application could be run in two ways. One, the driver application itself runs inside the yarn cluster, which means that in case the cluster is down, in case a particular node is down, that work is delegated to somebody else that yarn will take care of. Or the other way is running driver application on the yarn client, meaning the node from which you are launching the process, on the same node it will run the driver application. All right, this is unsafe. If you run driver application on the same node on which you are running, in case you get disconnected from the yarn cluster, then your process is gone. It won't be able to run it. In case you have asked yarn, you've told yarn, hey, here is my driver application, could you run it? So yarn will take the driver application and run it in the cluster. Okay, which means in case you get disconnected from yarn, it will keep on running it. So, but this is the yarn client mode where from the client you asked resource manager. So on the client in which you have logged in, there itself will be running driver application, talking to resource manager and executing its Spark applications inside the Yarn app master. Okay. All right. So Rahul's question is it possible to see the sample of this? Yes, I'll show you. No worries. Sekhar's question is, uh, I have a question in this pic. Resource manager in Spark RM or Yarn RM? It is Yarn RM. Okay, it is a Yarn RM. Urban's question is, why do we have three application masters? Okay, so this is also another application master. Okay, all four. It's just that I think that got pushed a little bit to that side. Okay, so it's basically four application masters. All right. So on every application or every node, you have node manager, and optionally there could be a Spark application master running on every node. Okay, it's just optional. There may be the resource manager while you're launching the driver application, you get only three nodes to work on based on the resource availability. All right. So, all right. So yeah, you are right in the sense that actually this has to be. I'll explain to you. So yes, all right, all right. I think there is a vocabulary confusion. I'll clear it. Very good questions. Thank you, Arpan. Let me try to explain properly. All right, let me just create a fresh one. All right, now here is a question, and there is a minor mistakes in diagram. So it's basically not application master per se. It's basically a container. Okay, container running the Spark application. You are right, Arpan, in that sense. So it's basically a container which is running Spark application, and this what you call Spark application master is actually running uh, a kind of outside. Right now, this drive application is running outside. It's talking to resource manager, and there may be some application master. This I'm not sure of, but there'll be many containers for our Spark application. All right, because you are right that application master will always be one, not many. Okay, so these are basically containers: container 1, container 2, container 3, and container 4. All right, and maybe there will be one application master in this. All right, one of the node will be given to you as application master, through which the work will be delegated to many containers. So this is a container. This is a container, not the application master. All right, I'll rectify it. All right, let me mark it somewhere. Good. We will, yeah. All right. So basically, in the client mode, the driver application is running on the node from which you have launched the process. And in case that node get disconnected, the whole application masters will be vacated from here and the process will be ended. Okay, and the way you execute it is using such kind of command. All right, let me try to log in into, I'll just open my console. All right, let me just so we can run it like this. All right, like this. So it says that bin spark submit is not a directory, so we can remove this bin and it'll get executed. All right, what is wrong in this? Will it work? It says that these examples do not work. Never mind. Let me just I've installed Spark somewhere, which by Spark. So it is there, and okay, it's basically existing at this place. And okay, we found the examples. Is it here? No, not really. Not really. Okay, so where is it? CD user. Yeah, I installed another copy of Spark. One is the client that comes with the usual Spark. So I was not sure if that is bundled. So there are two Spark right now. One Spark that has come with the Hortonwork platform, which we are using on our Cloud X Lab, and the second Spark I have put it in this folder, uses Spark 2. Here it's a latest version because we would need R as well. So that's the reason I've installed Spark 2.6. Now this is the beauty of having Spark over Yarn cluster, that we are able to have multiple versions of Spark parallelly, because right now Spark is just a client which we will launch and will talk to Yarn and will get the work done. So it is kind of installed temporarily and then removed from Yarn as soon as the work gets over. Okay, so so there are two Sparks right now installed, and both of them will basically get the work done over the cluster. All right, let me try to execute it. Now you can see that we are trying to execute Spark over this, and yes. All right, it says that you have to define this variable, okay, before you can you can launch some process in Spark, because you have to tell where is your name node, where is your resource manager. You have to tell that to Spark. That's why whenever you're saying master yarn client, you have to specify that. But if you are using say something like master local, then you don't need to specify the yarn cluster. Let's try that. Is it working? No. All right, where am I? Oh, that was in my console. Okay, here it says that opt spark does not exist. Okay, let me go back here. All right, here. So we have not yet defined this, and we are saying that we will run it. Where was that command? Here was the command. Okay, we will run it here. So we are basically right now running in the standalone mode. Then we will run in the yarn client mode. Okay. Okay, so it has finished and it says that pi is roughly 3.14, 3.14, which means that the area came out to be around 3.14 for 1 meter, 1 meter, 1 meter radius. Correct? So it basically divided the work on 11 nodes, 11 tasks. How many tasks did it create? Executors were two. Okay, number of executors were only two. So it executed it locally itself. Okay, without talking to Hadoop much. Okay, it executed locally. Now we said number of executor two. What does it mean here when we are running locally? When we are running locally, increasing number of executors will create parallel threads on the local machines. If your machine is having multi-core, then this number of executors can take advantage of multi-core in the local mode itself. So that's another reason to use the local mode. And there's another reason to use Spark, that you can divide your work on multi-cores very easily using Spark. So in case of say deep learning and others, where the use of Spark is to be able to easily divide the work amongst multi-cores on your machine. Nowadays, if you see the new computers, they are coming with many cores together. So you may want to utilize them in order to solve your problems. Okay. So right now it did not take advantage of multiple computers in our cloud labs, but it took the advantage of multi cores on the local machine. All right, on this machine where we are logged in. All right, now let's move on to the other example. I thought we had gone through this. Let's now, before we go with this, tell we have to tell Spark that this is my yarn, this is my Hadoop config. Either of them is fine, but for the say, I mean to be able to run it, okay, we should define both of them, and then let's run it in the yarn client mode, meaning the launcher driver will be running on the local node. All right, what's happening? What does it say? Oh, it's already in the use. Okay, maybe somebody is already running it. Yarn has already ended. Okay, actually it's already running. Let me try. How do you find out whether something is running on a port? Yes, it's running already. So, okay, can I change the port in some way? Let me try to change the port and see if can run. So somebody was asking in the last session that how would you restrict multiple processes of Spark of anything running. Okay, not in this session, it was in some other session. So the answer was to by blocking the ports. Right now, it's not letting me run another. Okay, it says, or it looks like it's not letting me run. So if any of you is running Spark parallelly, you can stop it and I can try to run it again. Looks like it doesn't let. It doesn't let me change the port. Interesting. Maybe I'll have to find out the property name for changing the port and then run it. Okay. So because it runs the master and that master runs on 4041, the driver application runs on that port, and probably that's the reason it's not letting me run. Did it give error again? It says there is no route to the host. And here again, it has failed to bind because it's already in the use. 4040 is already in the use. All right. Is it running something? Okay. Arpan's question is, what is this 10 in the Spark Summit? Here. Okay. The number 10 means we are dividing the whole circle into 10 into 10 area. Okay. Did it work? Did it fail? What happened? Okay. Nah, it did not run. It could not run because of the port blocking. Alright. Can I Spark Submit these things? Let me try to. I'm not here. Again, let me try to run it here. Alright, this seems to work. Uh, uh, uh. Yeah. So this one has computed the pi to be roughly this. Okay. And okay. So what difference did I make? Instead of using my installation, meaning /bin, all I did was I used the default installation, just that the library examples I provided. This library I provided by doing it user spark 2.6. Okay, so I changed the directory to spark 2.6, which is the new installation which I installed. Okay, but when I say Spark Summit, it ran the default installed program with the examples from this folder, user Spark 2.6. Okay, now there was a question, what does it mean by this 10? What if we do it 100? Okay, now the whole area of the circle will be divided into 100 into 100 number of squares. Okay, now the more number it is, the finer would be the answer. The more accurate will be the answer. So here there are some nodes which are failing, some nodes which are working. So it's trying its best to get the work done on whatever it can. That's the duty of yarn. So one of the node is failing, I think. This particular node is failing, while the rest, okay, no, this one is fine. This one is giving us a way to track. Okay, so this is the one which we are running. You can see that it has created a yarn application here, which progress is being shown by yarn application. Okay, because if you remember our MapReduce task, whenever we run it, it gives us the logs on 8088 port. Okay, so it has hooked itself to the yarn application manager to show its interface. All right. Now there is a very interesting question from Arpan. Question is, does it mean the Spark application is running on 4041 port and it accepts the submit request? Yes. And basically that application is running inside one of the application masters. It's a long running process. Now, since we have made it 100 by 100, it is going to take a long time. We should have divided it. We should have divided it into the multiple more nodes. Okay, so it has finished by now. All right. Now the accuracy of pi, did it increase significantly or did it change? Earlier, now it is this much. Earlier, it was this much. Okay, so it has slightly improved, I think. When we, this was with sections of 10 by 10, when we divided the circle into 10 by 10. Now we divided it into 100 by 100. Okay, and you can see value of pi, or you can just simply type pi, I think. Yeah, you can see the value which is given by Google is this much. Now you can see that this is more closer to, you can see the significant digit here is, third significant digit is 1, while here it's 2. So this one is more closer to the actual. So if we divide it further into, say, 200 by 200, the answer will be more closer. So if we divide it into 200 and we make the number of executors as 4, okay, so it should work over the cluster to get the work done. All right. Now this is the model, you can see, which is running here. This is the way we are tracking it. So you can see that we are seeing the logs of Spark through Yarn, even though this interface is coming from Spark, but the URL is that of Yarn. Basically, Spark has hooked itself into Yarn, and that's how we are seeing the logs. Okay, Yarn provides all these functionalities of hooking the log interface, hooking the various at various places. So okay, all right, so it has started working and it is running here. You can see that there is a lot of work going on in the background, and I'm not sure how many nodes it is utilizing. Is it utilizing only 2 nodes? Although we have, okay, good. Now you can see that after we have divided it into 200 by 200, pi is roughly 156. You can see it is more closer to what Google has. All right. So the more number of squares you divide it into the circle, the more closer will be you will be to the actual answer. All right. No, it doesn't. The number of containers we increased by increasing number of executors from 2 to 4. Okay. The number of parallel processing was increased by changing number of executors. Okay. So these are the details which we are providing, and Spark is going to indirectly ask the same thing to Yarn that, hey, give me 4 nodes and I need the driver with this much memory and executor's memory is this much, so that Yarn will allocate that much for you. In case there is a node which is not able to give you that much memory, it'll give an error. Also, please note that in case you say that, hey, my driver's memory is 500 MB and executor's memory is also 500 MB. So if it is not able to find a node which is having that much memory, it won't execute your work. It will not execute your work unless it finds that kind of memory. Okay? So those are the things to keep in mind. All right? All right, so I think we already did this exercise once, so it's more, the plan was to be more of a recap. All right, so we were able to run it in Yarn client mode where the master was running on the local node. Okay, the same thing could be done by saying Yarn cluster here. Okay, same thing could be done by saying Yarn cluster, and it will work in the similar manner. All right, so this is my where did my okay, it is inside the console. I keep forgetting because it looks so similar to my local console that I forget that I'm inside VETI or in my local machine. Alright, so it has started the process again. Let's see if it finishes. Now this time it's running, it sees that okay, it has started the cluster mode. Okay. All right. So you can see that before the process starts, it uploads the data into this Spark assembly onto the cluster. You can see that onto Yarn so that it can run. So every time you launch the Spark process, it's going to run this assembly again and again. Every time you do a Spark submit. Okay, so there is a big question from Arpan. Please comment if my understanding is correct. When we do a Spark Summit, it starts driver manager, okay, in the local machine. Okay, all right. So your understanding is correct. Just that the behavior Spark Summit will change. Will change. All right. So he says that it starts the driver manager in the local machine. Okay, on 4041, and it accepts the request. So okay, don't worry. I'll explain again. All right. Your understanding is very close to what it is. All right. All right. So yes, so we ran the example in three modes. One was on the local machine in which we did not utilize the yarn at all. We just ran the example on the local machine. This was this example. Okay. This, please note that you can run this happily just by downloading Spark from their website. Okay. You don't need any cluster at all for this. But this one, the second command, which is over yarn, you need a yarn cluster. And here we are saying yarn client, meaning the driver launcher, the one where our driver program, not launcher, driver program is going to run as yarn client. Okay. Second is that we say to, I mean, Spark Submit will tell yarn that, hey, take my take my driver also and run it somewhere inside the yarn cluster. Okay, which can execute the work on every node. All right. So those are the three ways in which the work can be executed over the cluster. Work can be executed not over the cluster. Work can be executed by Spark. All right. All right. So these were the three modes. Any questions at this point? So you can see in the class in this one, it's not application master. We'll just call it container. Okay. And right now I'm not able to edit it. Otherwise, I could have just removed it. Okay. So you executed a Spark Submit. Spark Submit talked to the resource manager. Resource manager created the driver somewhere on the cluster on any of the nodes, and then the driver started asking for more resources and then creating this Spark application on many nodes. You can see the driver application here. You can see these are the driver application. So driver application got created on one node and then it's talking to other Spark applications and getting the work done through them. So effectively, all I'm trying to say is that there is driver application and there are Spark application. Spark application is basically, it's a master slave kind of model. Driver application tells Spark application to do what it needs to do. Okay. Okay, so the difference between this mode and this mode is that this driver application is running outside Yarn. It's not running in case of Yarn client mode. This driver application is running on the same machine on which you started the process. Okay, it's outside Yarn. While in case of Yarn Cluster Manager, the driver application is inside the Yarn cluster. So that's the biggest difference. That's correct. You are right, Arpan. All right. Good, good. All right, should we move ahead? So that was a quick example of how to run an application in the cluster. All right, this was a way of looking at things from the application architecture perspective. But let's get into the developer perspective first. Let's try to understand how to get our work done through Spark. All right, should we move ahead? All right, Abhinav, Arpan, Giridhar, How, Rahul, Sachin, Shekhar, Valentin. All right, all right. So Okay, so we will keep on getting into these details as and when required. Okay. All right. So now let's get into the concepts and let's get our hands dirty by the end of this session. Okay. So today's session is going to be fairly hands-on. All right. Let me see if let's just close it because the process finished. All right. Let's see if it gets connected. There is something which is running on this port. I'm not able to understand. What is it that's running on 4041? Okay. Not this. I'm trying to see e.cloudxlab.com. Oh, it's a long running process of somebody, and ideally it should just connect with that one. Alright, it's a Spark process only. And who is that? Let me have a look. It doesn't show the details of what's going on. Alright, it doesn't show anything. Okay, okay. So is that my it's some other user who is running this particular user is running the Spark. All right. All right. We will see how we can work together with other users on the same port. Okay. 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 All right. So looks like, yeah. No, no, it's okay. I think it's not you, Valentin. Uh, it's somebody else running at this port. Okay. It's somebody else whose user ID is this. Okay. Anyway, never mind. There are many people using the cloud. We just need to figure out how can we make this environment to be shared amongst all the users. Okay, so I think it's not a problem. It has created another manager, so we should be able to run. All right. So I've opened the session. All right. So you can simply, even without this, you can simply say after logging to the console, you can simply run PySpark and you should see this kind of console. If you want Spark 1.5, you log into this particular folder, or you can simply you can do a cd user Spark 2.6, and then you just run bin.pyspark, or you can simply run PySpark. Okay, so that's completely okay. Perfect, perfect. So I'm able to launch shell. Are you guys also able to launch the shell here, or is it giving some kind of error to you? So just say 2 plus 3 and it should give the answer. Good, good. So we are all able to work together parallelly. All right. All right. So if you have to submit your job to Spark, you can use Spark Submit and you can give the program name on the command line. Okay. Whatever we do here, it can be cre- copied to the node, individual node. Sorry. Just give me a second. All right. So whatever commands we type here on the console, same thing can be saved onto a file into one file, say myprogram.py, and then we can run the same way, same thing in a batch way, not the REPL. REPL is read, evaluate, and read, evaluate, process, and display. Okay. So that's generally people call this console as REPL. Okay. Now coming back to it. So either you can run anything from the console or you can save the same thing into a file and run it in the batch way. All right. Or run it in a scheduled way or run it in a from a program. All right. So you don't have to do any of this. Okay. So I will explain. Now, before we start the process, so here is the console. Here, this is where you will write your, say, first hello world. I'll try to show you the easiest hello world right now. Okay. And then we see if you guys are able to do the same thing. Okay. Let's say my data equals to an array of four values. Okay. Now, my first RDD1, I'll talk about RDD and everything right now. I just want you to see if we can. Okay. So what we did just now is we converted our data which was in the memory into a resilience distributed data set by using this. Okay. So I'm saying my data is this and okay, now we have RDD1. RDD1 is a parallel collection RDD, as in resilience distributed dataset. Okay, now if you want to do anything on this, we can get it done very easily. Okay, so let's try to just square these values. We'll say define a function. If you remember our the last session, we, on Python, we're defining a function. Okay, let's define a function and we call it sq. Okay, we call it sq, and what it does is it basically squares any argument you give it. All right, so now we have a function called sq which will square anything you give. On top of rdd1, we are going to run sq on every element by using map. Now note that this map is different from Python's default map. Python's default map runs everything on the same machine. Okay, while this RDD map which we are running, it's going to call Spark and will get it done over the Spark. All right, because this RDD1 has been created by Spark Context and is a resilience dataset which is loaded as a shared memory on the whole cluster. Okay, we will get into more and more details about RDD because RDD itself is a big concept. For now, you can think of RDD as some dataset. Okay, now on this dataset, we are running Square as a map, meaning this square function is going to get applied on every value of RDD. Okay, now we will assign it to another RDD. These are some random variables I've created. Now rdd2 dot collect. We are bringing data back from, okay, we are bringing data back from RDD by using collect onto the local node. Now, the moment we said collect, only then the job started. Okay, only then the job started and it has finished the task. Okay, and you can see that SQRS is the variable which has been brought locally after the squares have completed. Okay, now let me try to copy this section to all of you. Okay, and let's see if I can share everything with you. Okay, so here we go. All right, so make sure whenever you define a function, test it properly before feeding it to the Spark. All right, this is probably the easiest way of testing and understanding Spark. All right, let me just send it to all of you. And okay, Arpan also. All right, good. So everybody with me on this. So we were able to happily run our most simple Python program. Okay. All right. So yeah, you don't see an output because you'll have to say print sqrs. All right. Should I try to run? Okay, let me go to my web console. This thing is quite confusing me. Let me just close my console. All right, and now the console is getting closed. Good. I think this is comfortable for me. All right. Now here, let's try to run something what Shaker is suggesting. Okay. Let's try to. Let me just go to my home folder. Here, let me create this file called my hello world.py, and in this I'm using nano editor. Okay, so let's try to see if we can run it. We can say spark submit, and also I think we need to do a chmod plus x my hello world and say spark submit. Okay, the command exists. Now we can say, okay, looks like I always create files with my. Okay, so here what we have to do is we have to do a little different thing. We will have to use, okay, we will have to use an import. Okay, we'll have to import the SC Spark context. We will have to say PySpark. Okay. Okay, so we can actually say things like this and Spark context. All right. So we'll have to include this file in our, okay, my hello, and here we have to include this file. All right. So what does it say? It says that unbound method parallelize must be called with Spark instance as the first argument, got list instance instead. I think we are making a minor mistake. Yeah, that's right. All right. So you'll have to scroll a little bit up to see the answer. Okay. Here is the answer. You can see that. All right. If you are okay, then I'm going to make my this current folder as chmode 755 dot. Okay. So if you want, you can go to, and my username is Sandeep Giri. This. So if you want to copy, you can simply say cp dot dot. Okay. Cp dot dot slash my hello.py to your current folder. This way you will get this particular file in your home directory. Okay. All right. I have put it there. Good. So, all right. Okay. So let's just go back to what we were doing. Map square, what does this command do? This command applies this square function on every element of on every element of this array. Okay, so this map function is basically the trick, the main work which is being done in a distributed fashion. So this square function is taken to every element of this data set which is spread across your cluster, and then whatever is the result of a square is collected in another data set which you are collecting, which you are bringing back to the node. Okay, so if you see that, what's happening is that you're taking this function sq on and applying on every element. What does it mean by applying? It means first one will be passed to sq, and which means the result is going to be 1 into 1. Okay, and that output will be kept in another array, and then 2 for 2 the square function will get executed, which means 2 will be passed as an argument to square, and then the result will be saved. Okay, all right. And similarly for 3, sq3, sq4, and so on. This basically is equivalent to saying This basically is equivalent to saying RDD2 0 equals to 0 equals to, or you can put it this way, square of 1, comma, square of 2, square of 3, and square of 4. Make sense to you now? It actually means this. Grida, did I make sense to you? All right, brilliant. So is everybody able to see that program which I've given to all of you? It's basically kept in this folder, in my folder, not this one, this folder. Okay, I'll just put it in the notes so that if somebody is coming back, yeah. Okay, and then you can simply run spark submit space my hello world.py. All right. All right. So if you execute groups command, do you see KBD in your groups? These are the benefits of having a CloudX lab so that we are able to coordinate quickly and easily. Okay. KBD is no big data because see our CloudX lab is being used by other instructors also. So I wanted to see if you guys are in KBD group, then I would just make my 750 for the current folder so that only our students are able to access my home directory. Good. All right, so now only our students are able to access my home directory, which is good. All right, now coming back to it, so that was our hello world on Python. Now let's try to do the hello world on Java. Okay, so the project we have created a sample project in Java, which is in the LMS. Okay, you can have a look at this example project. Okay, let me try to download it. It's little too big a project. Okay, don't get alarmed because it has all the libraries of Spark that is required. So I've kept it at a single place so that you don't have to hunt for all the libraries. Okay, it's good to have for the first time. Although those who are used to Maven, they can easily create a Spark Maven project. All right, looks like it's going to take a lot of time. I think I would have somewhere. I would already have it in my Eclipse. So you can just download that project, import it in your Eclipse environment. Okay, so if you have Eclipse, you must have installed Eclipse. You can import the project to the Eclipse and Looks like it has not been. Alright, so here workspace training. Let's try to switch the workspace to another one if I have there. Otherwise, I'll have no other option than downloading it and executing it. Alright, so if you're downloading, you can start downloading parallelly. I don't think it'll hurt too much. Arpan, if you could not get the file, let me just put it here to you also. Okay. Alright, doesn't look like I have a copy. I would most likely have to Spark example project. Alright, good. I have a copy like this. Okay. Alright, it has done the job. I'll just move it to my home folder. Yeah, here it is. So once you download it, you will have two sections. One is the simple word count example. Other is this class. These are the compiled versions. Other than that, inside here, you will see this big Spark assembly. It contains all the things, all the libraries that are required, though all of those are bundled together in a single one. Okay, now it's good that I have downloaded the project. So wherever you downloaded it, okay, all right, let me just, all right, so two steps. One, download this example project, okay, unzip it, and parallelly install Eclipse on your machine if you are interested in creating the Eclipse one. Create a fresh workspace, or if you don't want, it's okay completely. And then import the project. All right, import the project. All right, let me try to import the project. Here you can see import, and then we can see existing projects into workspace, existing projects into workspace, and where was it? In my home drive, and here. Okay, this particular folder contains my project. The Spark EX contains the project, and you can simply say open, and it will identify that it has found out the project. You see that? Now it says that here, right click, and if you go into properties, if you go into Java build path, okay, it says that this particular file is missing. Okay, so you can simply go into, say, this one and remove it from the libraries tab. You remove that one and say add external jar, add external jars. Okay, and browse to this folder where you downloaded. You will see this jar folder as well, jar file as well. Now we have everything set up. All right, now you can see the word count is done. Okay, all right, so this is a very simple word count example, and here we'll change this to a.cloudxlab. Okay, and there you will already have under data, under mr, under word count, and input. Okay, this is the file which we want to churn, right? Let's have a look at this file. We'll say hadoop fs minus ls, and Looks like Arpan could not copy the file. Let me try to do ch mode. Now try Arpan. Okay. Alright, you could already copy that. Good. Alright, here we go. So what we did just now is we saw that there is a file already. This is a file which we are going to churn. Now here we have changed the name node's name, and we have mentioned this as HDFS. And this is an example of Java way of doing the word count. We start the Spark configuration or context, and then you have the Java Spark context. So we first get the entry to config, then the context, then we load the data from this text file into this RDD called lines. Then on lines, we are running our flat map. Now this is another class which we have to create, and we have created as an inline class here. And this flat map does nothing other than splitting by words, and that's all. We have just taken 4 words out of it. We are not even doing the word count. It's not a word count example. All right. So that's it. All right. Let me try to export. All right. So here I can say export, and I can say jar. Alright, I'm saying the jar file. I can browse to any location. I prefer it to be in my downloads folder, and I'll say hello world java dot jar. Okay, just like I'm putting any name. And what does it say? Jar creation failed. Isn't that correct? Why would it fail? Resource is out of sync. Alright, just let me remove all of this. Okay, project, clean all projects, and then I can say file export jar. Let me just put some output folder. Let's say hello world. Hello world. Okay, hello world Spark. Alright. Just a second, let me first check if it is created or not. Alright, so I think it has done the job. In case you want to see what is there in the locally created file, you can always use a command called jar -t. Okay, you can see there is a way to just have a look at jar -t. Okay, and see whether it contains the output you are looking for. So what was that? WC Spark, or what was hello world Spark. Exactly is happening? I'm just confirming whether it has, yeah, it has the files which we are looking for. You can see that there are all these files. These are the two files which we need in the output, right? These are the binary compiled one. Okay, so nothing to worry. Now let's upload this file. So we'll upload the file in here in two steps. First, we will put it in HDFS and then we'll copy it to the console. Okay, so how do you copy it to the HDFS? By going into the hue and then going into the file manager, and clicking on upload. So we are uploading our jar files itself to the HDFS. Why? Because I don't want to get into copying through SSH and PuTTY or installing any other things. I'm just trying to use the HDFS, the hue, as a way of uploading. Okay. Why did it give an error? So it failed. Okay. How can I delete these files? I'll just move it to trash. Alright, let me try uploading again. I hope this time it'll work. Maybe it's in the kind of modification mode. No route to the host. Why is this happening? Am I disconnected or something? Why doesn't it let me upload? What is going on with this? Why does it fail? It's completely running fine. The name node is running fine. Secondary name node is running fine. All data nodes are up. And yeah. Alright, let me try to put it in a folder or something. Is it trying to interpret these files? Mm-hmm. This is crazy. Now once I've renamed it and I've used upload at zip file, it worked. You can see that now it has uploaded. Never mind. So yeah, we have uploaded it. I'll have a look at it after this session. Move my Spark. I'm going to move. Okay. All right. So I have uploaded this file into HDFS, although I had to take a strange route. I zipped the file and then uploaded using the second option. I don't know why is this happening. All right. Let me just try to download it into the console. Let me try to download it into the console saying Hadoop fs copy to local and this using star.jar. All right. So here you can see now hwspark.jar is there. Okay. Now once we have we have done many steps here. First, we downloaded the project from LMS, created a fresh workspace inside Eclipse, imported the project, fixed the library problem of Spark by removing the initial reference and pointing it to the newly downloaded file. And then once we are done, we cleaned the project, exported the jar, we checked the jar if the files are there inside the jar or not by unzipping it. Then we uploaded it. Instead of using SCP, we used we used HDFS. We uploaded it to Hue, and then from Hue we downloaded it in the console by using copy to local. All right, copy to local. And once that is done, now we will execute this command. Okay, what does this command do? We are going to execute this, and the name of the file is hello world sprk. Okay, and not dot dot, it's in the current folder. Okay, let's try to do it. Let's try to go to this console and try to see if it runs. Okay, looks like it is running. All right, looks like it is running. Where is the output? Yes. So it has read the first four words out of that file. Correct? That's what we were trying to do here. We are trying to read first four words. We are saying words dot take four and then iterating over the four words and printing it on the sysout. Okay? So we just able to print the four words from that file. Those four words you can find out what are those four words. If you go to this particular location, and you can simply say edit and all right. In this, what are the first four words? The project Gutenberg ebook, correct? And that's what it has printed to our screen. The project Gutenberg ebook. All right. So we were able to use Eclipse here. Also note that the way we have created map function is little more lengthy than the Python one. We have created first a class instead of a function. Okay, because we can't just pass the function as an argument in Java. We have to create a class which implements a certain base class. Okay, and then we implement the special method called call. Okay, in which we do the actual operation. All right, so it's little lengthy in case of Java. All right, it is equivalent to saying dev my function, and whatever is the string being passed to it, we are returning x dot split. Okay, so these many lines you see here, are equivalent to these two lines in Python. All right. All right. Okay. Sorry for not looking at your questions. All right. Okay. So here there is a question from Arpan. Arpan is suggesting that alternatively you could use Ambari file views if configured. Let me take a look. Let me take a look. Okay. If that happens, it'll be great. All right. Now, Rahul's question is, what about Java Lambda? Good. So in Java 8, Java came up with Lambda. All right. So, but still, I would prefer to avoid Lambda for some time. Okay. Lambda makes it possible to create a function very quickly, anonymous function very quickly instead of defining it somewhere. Okay. Lam- if I will not get into the lambda philosophy because lambda is a big deal in programming. So lambda is the mother of most of this functional programming. So don't confuse it with lambda architecture because it has nothing to do with lambda architecture. So lambda means in programming language the anonymous function. Okay. For, okay. So that is anonymous function. Anonymous functions are now supported in Java. All right. But I would still avoid it for some time because it's not a great practice to write a code which may not be compiled by many people. Okay, all right. So we were able to run our Spark Summit easily. Instead of this line, what we'll do is upload to Hue and then copy by using Hadoop fs minus copy to local. All right, and that's pretty much. All right, is everybody with me? We missed the break time. Let's take a break now. All right, so I'm back. Should we start now? Great, great. What's happening? All right. Hey Abhinav, hey Arpan, hi Gridhar, how Sachin, Shekhar, Valentin. Should we start? Everybody back? I see only Shekhar and Arpan. All right. So we were able to successfully run our code in three manners. One was using the interactive shell. Second was saving the same code into the Python program and running it. Third was using the Java code. Okay. So I hope that these examples are very clear to you. All right. Shekhar is saying that he got an error saying, okay. I got an error saying Spark submit hello. Are you executing it from the inside Spark? You are supposed to run it from the shell. If you exit, like from dollar sign, you see the dollar sign? From there, you are supposed to run the command, not from inside of Spark. I guess you're running inside of PySpark. Okay. So if you run it from inside Spark, I think that is the error you will face. All right, good, good. So we have been fairly successful today in able to execute everything as a independent program. Now let's move ahead. Is anybody else facing this kind of error? Good, I'm happy. Sekhar's program is now working fine. Brilliant. All right, all right. So that was our and in case you are looking for Scala, then you can go ahead with Spark Shell. Spark Shell is basically the Scala way of getting things done. All right, there we go. All right, so you could use this one. All right, so here you can write your Scala program to execute on Spark. All right, now next we go ahead with the. All right, so one of the most important concept which was introduced in Spark was the idea of an RDD. In every data set, whether it's a In every data set, every data oriented program, be it SQL Server, be it R, or be it any other data oriented language, everywhere it's the data that comes first. Everywhere there is an idea of something called a data set. Okay, in Spark you must have heard about, in R you must have heard about what do we call a data frame. Similarly, when we talk about database, there is a database table. Similarly, when we were talking about pig, if you have studied pig as part of Hadoop, the whole idea revolves around data sets, or they call the data sets as relations. Okay, so in the similar manner, the story in Spark starts with resilience distributed dataset. It's nothing but a collection of data elements or a representation that would lead to the data. Okay, it's a representation that would lead to the data. Okay, and the qualities of RDD is that it is distributed on multiple machines. Next is it is resilient in the sense that in case one RDD fails, because RDD is located on multiple machines in the network, let's say one of the machine goes down, then that particular part will be brought back by doing the recomputation. Okay, by doing the recomputation. Now the interesting part about RDD is that it is under the hood, it has got two representations. First representation is that it's a kind of step saying when people try to take the data from this, do these steps and get the data. Okay, it's a kind of execution steps. Second representation is that it is actually the data, but for the end user it is displayed as data. So the moment we create an RDD, it does not mean that all of the data has come and got loaded into Spark. No, it is just when we say load data into an RDD or parallelize my in memory, it just maps it. It just keeps a reference that hey, this data means that file has to be loaded from the HDFS. So when need arises, only then Spark will go and load the data. It won't be loaded by default. Okay. So so RDD is, you can think of RDD as a data set, whether available right away or available on demand, as in when you are asking only then it'll go and load the data. All right, next is the other way you can when you think about RDD, you should think about RDD in this following manner, that RDD is kind of collection of element partitioned across the cluster. Okay, you can see that this RDD is spread on four node or four machine 1, machine 2, machine 3, machine 4, and this RDD has been prepared out of a file from HDFS. Okay, it's an immutable data distributed collection of object. Immutable because you do not change the RDD, you only prepare another RDD from one RDD. Okay, and it can contain any data type, be it Python, Java, or Scala objects, including user defined classes. It can contain any data on the cluster. All right. All right. Is everybody clear about the immutable? So when we say this is an RDD, RDD is a data set spread across the cluster. Okay. In case one of the node goes down, it springs back uh, on another node. Okay. But nothing gets lost. So that's why it's called resilient. Resilient means something that springs back, as in something it fails, it recovers by itself. Now this RDD can be persisted in memory. Let's say there is an RDD which is being which ha- is prepared out of 10 20 steps. And every time you say rdd.collect, it goes back and does the recomputation and prepares. So in case you need this RDD again and again, you can say rdd.cache and everything will be computed and kept in the memory. So you can use RDD as a cache. Sometimes when you need a particular data again and again, and you are okay to sacrifice the cache, sacrifice the memory, then you can load it, you can pre-prepare it. All right. Otherwise, nothing will be loaded in the memory. It'll just keep a note that, okay, this RDD means the data has to be loaded from the server and we will be running the map on that data, and then this RDD will be prepared. Okay. So in case you need a certain RDD again and again, you can load it in the memory. And in case a particular RDD fails, then it will be recomputed from the beginning till that point. All right. It can have any data type but has special data type for key value pair. So although it's nothing but an RDD, you can think of RDD as a very big array of elements. It's an array of elements, and not all elements need to be of the same data type. Okay? Spark does not enforce that kind of strict type safety that all the elements have to be of the same data type. In an array or in the RDD, the elements could be of any data type. Just that since Spark provides a lot of functionalities in which we need to identify each element, such as while joining one RDD with another for performing joins, you would require a way to identify each record of the RDD. In those cases, you would have to define the each element of the RDD in a key value pair. Okay. Therefore, the key value pair has got a special significance in case of Spark. Although every object is accepted as part of RDD, but key value pairs has got special significance. Now every RDD supports two kind of operations. One is called transformation, other is called an action. What does transformation do? It transforms it transforms a data set from one shape to another, or it produces another RDD from one RDD. Okay. It does not bring the data back to the node from which the call is coming. It basically prepares another RDD, which will be loaded on multiple nodes. While action is something which forces the computation. When you execute an action, only then Spark does some work. Otherwise, every transformation is just a kind of a note to Spark saying, hey, can you prepare RDD out of R1, RDD1, RDD2 out of RDD1? It'll say, okay, fine, I've made a note. If you execute the step which we did earlier, you will notice that unless we said take or collect, nothing happened. Okay. So basically, RDD supports two kind of functions called transformation and action. All right. Each element of RDD across the cluster is run through map function. Each element of RDD is run through the map function. We will see these examples more meaningful. All right. So there are, how do you create RDD? RDD is created in two manners. One, by loading an existing data from a remote data source. A remote data source could be HDFS. Remote data source could be any other file system or a database. The second way would be to convert an in-memory object to an RDD. For example, here you can see in the first one, you'll see that we have prepared these RDD out of this file. Okay. And in the second one, you can see that first we have prepared a big array of 1 million numbers. We have prepared, this is a very big 1 million elements, and then we have converted this in-memory array into an RDD by using sc.parallelize. These are the two basic methods of creating an RDD. All right. Now, the two operation which we talked about, which we do on top of RDD, are transformation and action. These are the class of operations which we do. Either it's called transformation or action. Under each of them, there are many functions involved. All right. Under each of them, there are many functions. We will go through most of them by the end of this course. All right. So a transformation is basically converting one RDD into another by applying that function or the transformation on every element on the cluster. You see, this RDD is spread on 4 nodes. Each of node have some elements. Okay, now this transformation will be applied on each element, producing another another data set. Okay, that is transformation. All right, so the examples of transformation is map and filter. So using map, our square function, the script we talked about earlier, the square functions were applied on every element. Okay, 1 got converted into 1, 2 got converted into 4, 3 got converted into 9, and 4 got converted into 16. Okay, so transformation was the function which we passed called sq that did the transformation from one RDD to another RDD. All right. So here is another example where we are multiplying all the elements by a certain value. Okay. So let's define a function called multiply by 2. Is it clear to everyone? So we started PySpark. All right. And then we are saying return x into 2. Okay. Let's test whether this function work or not. You can see that it works fine. Okay. Let me move it to another window so that I can switch quickly. All right, here we go. So we are here and look at this. What's happening here is we are creating an array. You can see how many elements does it have. These are really too many elements. Such a big mistake. All right, then we convert this big array into an RDD. Nums is an RDD, which is, you can see that, and then we multiply every element of this big RDD by 2. Right now, it has just made a note of it. It's not executed yet. It'll execute the moment we call an action. Take is an action while map is a transformation. Okay? So map is going to convert 1 into 2, 2 into 4, 3 into 6, and 4 into 8. Let's take a look whether it worked or not worked. You can see that it has worked well. All right? Good. So we can do delete ARR. All right? Is the idea of transformation clear to everyone? Giridhar's question is, what is the difference between collect and take? Collect brings all the records while take only brings few. Like here we are saying take 5, it's bringing only 5 records, while if you say collect, it could have brought uh, all 1 million records back. So transformation on RDD is like logical plan. You can think of it that way. Okay? Transformation is basically kind of a thing you have executed. It has made a note of it. Okay? At the moment you say action, and then it will start doing all kinds of transformations required to required to be executed before reaching to the dataset on which you have executed an action. Okay? How's question is the transformation is run parallel on different partitions in a cluster. Yes, that's exactly correct. So also these are called partitions of RDD. There are 4 partitions of this RDD. All right, is everybody with me? If there is any doubt, any confusion, please feel free to ask. Otherwise, that doubt will accumulate and it'll become difficult later point of time. So please feel free to ask immediately as and when you get a doubt. Okay? All right. Now the action. Action is something which brings data to the node or which saves data somewhere. Action means we want the results. Okay? Action says that, hey, I want the results. Now, the moment we call an action, then the whole chain of transformations will be executed. All of them which are depending on this. Okay? All of the chain of transformations on which an action depends upon will be executed. Okay? You can visualize this in the manner that let me try to show you. All right, let's try to think of this way. We have this data from a file. Then we did a transformation called, let's say, flat map here. Flat map. Okay, we got another data set. Say we got words out of lines. This was our lines. Lines got converted into words, and then words got converted. Let's say we converted them into capitals. Capitals. Similarly, lines, there is another thing that happen is, let's say, uh, line length. Okay, and we got, let's say, this flat map is nothing but map, and we got line lengths. Okay, now if we say capitals dot take, then this part will be executed. If we say capitals dot take, then this part will be executed. If we say line length dot take, only this part will be executed. Okay, the action on each will only force this side or this side. Okay, you're getting my point? When we say lines dot flat map and we get words, then words dot did another map and we got capitals. Then if we say capitals dot collect, then first lines will be loaded, then words will be computed, and then capitals will be executed. Okay, so this is how if we think of the transformation and the actions. All right. Valentin's question is, I'm not sure I got the difference between map and flat map. Can anybody quickly answer? All right, interesting. So I got Arpan and Valentin the same question. So map is one-to-one transformation. One input gives one output. Flat map is one-to-many. Okay? So if we have to convert line into words, what will we use? Anybody? Line into words, what will we use? Map or flat map? Correct. We will be using flat map. All right. So action will involve the whole cluster. Action will cause the whole process to execute. Action is like pressing run button on your script. Okay, it actually executes the whole thing. While we are writing transformation, this that, Spark is just making a note of it. It's waiting when you will call an action. Okay, all right. The example of action was take. The moment we said take, only then the whole process started. Otherwise, it was just making note of. We said, okay, please load this data. Okay, it said, okay, I have made a note of it. Then we said, can you execute a map? It said, okay, fine, I have made a note of it. But the moment we say take, then it actually worked. It did not say, I have made a note of it. Instead, it did the actual work which is required for computing DBLS. DBLS is prepared out of nums, and nums was prepared out of parallelizing this. Okay, so all of this thing will happen the moment we say take. So take is an action. All right, now comes the first transformation after map. The first transformation after map is filter. So there are many transformations. Okay, first one of them, which we have already talked, is map. The second one is flat map, and third is filter. What does filter do? In case you have a big data set, you only want few records out of it. Okay, in those case you would apply a filter. Now filter takes a function as the argument, and this function will be the judge. This function is going to be your criteria of judgment, whether to keep an element or to discard it. Okay, so out of one RDD, we'll prepare another RDD using this filter function. So, using filter function. Now, question to all of you, which one, evens or num, will have more elements? Nums will have more element. That's correct. So filter will always lead to equal or lesser number of elements in the RDD. There's a question from how that action is like a reduce. Not really. Action is more like if you had used pig, the moment we said dump or we said store, that was action. Okay, reduce in case would be another function. I'll show you. But interestingly, reduce, when we use reduce in the context, it will actually be an action. Okay, so I'll not try to keep a mapping between reduce and this. Instead, I'll keep segregation based on transformation and action. Okay, because in reduce by key is a transformation in certain cases. Okay, so yeah, it'll be difficult to think of it that way. All right, so good. So we are able to filter the records. Let's try to take this range, and where is my record? I think we have already defined here. We have array. No. All right, no worries. And then we say nums. Nums is there. Good. Nums, let's check if it has some data. Good, it has some data. Now we say nums. We define a function called def is even. So is even a function which will return true or false. Okay, which will return true or false. Now what does it do here? It's saying if the, okay, it's basically testing for even. You can see is even 0, it says true. Is even 1, it says false. Is even 13, it says false. It is even 130, it's true. Correct? So is even function is working fine. Now we will say that only evens equals to nums dot filter. Nums is the same data set which we already created earlier, and we are passing the function name as the argument. Please note this part. We are passing function name as the argument. Okay. So now we only evens would contain the only even numbers. So let's just collect, say, 1000 records. So it only has even numbers. You can see that there are only even numbers. That's right, Urban. That it'll be filtered by is even function. All right. You can see that is even was executed on 1. It says, okay, it's false. So it did not put that in output, while is even 2 gave a true, therefore it was kept in outside. So basically, your is even function is going to be executed against every element in RDD. In case is even says true, then that element goes in the output. Otherwise, the element is not put in the output. Correct? So that is our filter function. Now next is the flat map. Flat map is just like map, just that one one element of an RDD can result in many element of an RDD. So let's imagine that while we loaded the file, each element contains a line. Okay, the moment we when we load a file, when we load a text file into into this into the into Spark, into an RDD, it's generally a line. Let's see. Let's say that we have loaded lines RDD equals to sc.parallelize, and this is a dog and with the name Jerry. So you can see that there are two lines, line 1, line 2, and we have just loaded that as an RDD. Now to convert this line into words such that our resulting RDD is one word per element. In those cases, we'll have to use flat map. Now the kind of function we have to give it to flat map is something that returns an array and takes a single element and argument. So two words, you can see there is this function called two words. It takes a line as the argument and returns an array of words to us. All right. All right. Now the if we say, let me try to do it. So let's define two words function where it takes a line and returns line dot split. When you don't give an argument, it will automatically split the line by space. Okay, let's try to see if it is working or not. Okay, this is me. Okay, so I forgot. No, it's not working. I forgot to write return. You can see that we have converted a line into array of words. All right. Now we can run the lines RDD, and we could say lines RDD dot flat map, and we pass this function called two words, and okay, we call them words equal to this, and now you can say collect, or yeah, you can say collect, and you can see that the lines have got converted into this. Okay, now visually it wouldn't make much difference to you. Here the most important part is, earlier this lines RDD was composed of very big text. Now each element is an element is basically e- each word is an element. All right, so is flat map good for everyone? Now the question from Sachin is, are RDD always in-memory objects? When does memory get released? When does garbage collection happen? Good question. So first I'll try to answer no. RDDs are not always in-memory objects. So these objects which you have just seen, none of them are in memory. These are not in memory. Words is nothing but a note saying that words which should be prepared out of lines by using flat map. So words is nothing but in the memory of in inside Spark. All it has done is it have made a note saying words is equal to lines dot flat map. That's all. Words is not consuming any memory right now. It's very small memory, minuscule memory it's consuming. Even if words represented a data of few GBs, still it would contain few bytes of memory. But the moment you say words.cache, okay, the moment you say words.cache, the data is cached in words. All right. This way, I think it has not cached. All right. Words.age cached. dir. You can always say dir and check what are the functions available to you. Yeah, this is cached. All right. So basically, you can the moment you say cache, only then it consumes memory. Otherwise, it will not be in the memory. Now, Arpan's question is when we see functions, why some functions are underscore? Those functions are basically private functions. All right. Good. Now, there are other transformations such as union. What does union do? Union basically joins two data sets and combines the two records. You can see that 1, 2, 3 and ABC, if we union them, the resulting would have both the data from both the data sets. You can see that. Let's try to do it. Oh, why does it say? Yeah. All right. You can see that it has combined the two records and given us the result. All right. Is union, flat map, and things are clear to you? All right. A question from Arpan. How much memory each RDD is taking before and after caching? You can find it out from the console, from the what do you call, the server which is running right now. Okay, not here, not here. It'll be very up. Okay, so e dot cloudxlab dot 4041. All right. For some reason, it's taking too much time. All right. Union is only between two sets. That was Valentine's question. All right. All right. So here it's not treating it like a the set, but yes, union is always between the two data sets, and we need to delete the last element from here. Okay. We can do union between two RDDs. Okay, these are two RDDs A and B, which we are doing union, and after union, the elements of both the RDDs are copied to the new RDD. Union is a transformation. So we are right now talking about only transformations. Good? All right. So the other way you could see the lineage graph, we call it lineage graph, meaning the history of a particular RDD. Let's see that input RDD got converted into two RDDs. One is called errors and other is called warnings. Okay. Now errors and warnings can be again combined using union and capped here. Okay. So input RDD could be the full log file out of which we prepared two RDD by filtering. One is called error, other is called warnings. The other debug messages have been ignored. Now, if you just want if you just want to combine errors and warnings together, you can simply say union. All right. You want to take a real example? All right. Let's try to take a real example. In here, in the slash apps, not apps, let's take app logs. Okay, let's try to take app logs. And what is my, let's take Sandeep. Okay, so here, this is, I think this is my folder. Oh, I doesn't have any. Okay. All right, you can see that there are so many logs here, and we could simply load both the files. But this is binary data. We'll have to figure out. Alright, I don't have a good data here right now. Okay, okay, so what can we do? So if we go var log and let's say mail log. Okay, and let's say I go into Hadoop, MapReduce. Alright. Alright. Never mind. I think I don't have okay, du ls minus h boot.log. Okay, it's very small file. I don't have a good data right now. Never mind. So alright. So I think we will give a demo of a more exhaustive application once I have some logs. Let's continue our discussion on this. Alright. The action which we have already talked about is example of action is collect. Collect brings all the elements back to you from the RDD. Collect gives you the result. Collect is more like saying print. Okay. So the most important part to know about collect is it is going to bring data back to you, but is going to put it in the memory if you are assigning it to something. That means that your node should have enough memory available if you are collecting really huge data. Okay, mostly it is impractical to try to bring the whole RDD back to your node. Okay, so generally we do the computation as much as we can on the cluster, and whenever data is comparatively smaller, then we gather it. Okay, otherwise we just save it to the HDFS or somewhere. All right, now here you can see that it is basically going to bring all of this data back to you. Next is take. Take is like collect, but it brings only few records, the number of which you have specified as the first argument to take. So if we say a dot take 4, it is going to bring only 4 elements back to you. Count. When you say count, it basically is another action. It's equivalent to uh, counting. All right. So internally counts on separate nodes, and then it brings all the counts from all the nodes and then sums it up locally for you. Okay, so count gives you count, and that too is distributed. It asks all the nodes about from each partition to count and give it the count. All right, it's going to all right, it's going to give counts. All right, there is a point from how the point is, can we compare can we compare the approach between Hadoop and Spark, okay, to give us the complete picture? Why we said Spark is much faster than Hadoop? Okay, so the important part to understand, Spark is against Spark's comparison is against MapReduce. Okay, not the entire Hadoop per se, but only MapReduce. So the difference between MapReduce and Spark is in the implementation. Okay, implementation. The Spark has been designed and the implementation has been done in a manner that it should give the results really fast. Okay, while in case of MapReduce there was only one syntax called map and reduce, here it's a big detailed, it's a here in case of Spark, there are many functions, not only MapReduce. Therefore, we are not limited by only MapReduce. Okay, right? So, so the difference between Spark and MapReduce is one is implementation differences such that if it has to fail fast rather than waiting for so many nodes. Okay, Spark tends to give you the great results by trying to utilize memory. Okay, memory utilization. Second, in Spark, it's not only map and reduces, but far more functions are made available to you. Chaining was very difficult, very time consuming in MapReduce. Okay, while chaining in case of Spark, as in case of Spark, chaining is an obvious step. Meaning we'll run first map, then we'll do is reduce, then we'll again run the map, and so on. So chaining is very straightforward and quick. In case of MapReduce, chaining was not a standard process. Meaning MapReduce phase takes the data from the disk, saves it back to the disk. While in case of Spark, it takes the data from the memory, saves it back, puts it back into the memory. That is probably the most important difference. Okay. In one, the in and out both is HDFS. In MapReduce, input data as well as output data was in HDFS. In case of Spark, the most of the data communication happens in memory. So that's one of the very big differences. In all MR, all functions are action of Spark. In Spark, things are internally optimized using dark and yes, that's correct. All right. Now this every time we call an action, entire RDD must be computed from the scratch unless something is cached. Every time D gets executed, ABC would run. For example, lines equal to sc.text file, few lines equal to lines.filter, uppercase lines equals to few lines.map, and uppercase line.count. This would cause first the loading of this file, then computation of few lines, and then uppercase line, and then this. Okay? Every time this statement number D, every time you execute statement number D, A, B, and C would be run automatically. All right. When we call when we call a transformation, it is not evaluated immediately. It just makes a note that hey, I have I have made a note of your transformation. We will do it when the time is correct. We won't do it now. Okay, whenever we encounter an action, then we will run it. It helps Spark optimizing the performance. It helps Spark optimizing the performance and keeping the data in the memory for a short period of time. It's very similar to pig, link, etc. Instead of thinking of RDD as dataset, think of it as instruction on how to compute or transform the data. Alright, great. So we will continue our discussion from lazy evaluation tomorrow and see you tomorrow. Alright, bye bye. Have a good day. Yes, we have a class tomorrow, that's right. Alright, see you tomorrow. Bye bye. Have a great day. Good night.